A clever way to build a what is called as a built-in logic block observer. Built-in logic block observer. Remember what an LFSR is. Okay, what is an LFSR? This is an LFSR or a PRPG. So this is PRPG. If you use it as a shift register, it will look like this. So this is our serial input, serial output. If you want to, this is a shift register. If you want to use it as a parallel in, parallel out register, then the parallel inputs will go to the D. These are D inputs and these are the Q outputs. And this is a clock. I have not drawn the clock in all the others, but we could draw. So these are my D inputs and these are my Q outputs. Here this is my D input, Q output. And the clock goes to all of them. What about the multiple input shift register? I'm sorry, signature register. That would look like this. We'll generate the feedback line and we will XOR these guys. And this is my signature register. This is my signature. Okay. So what one could do is one could build a single circuit called as a BILBO with two control inputs, C0 and C1. So if C0, C1 equal to 0, 0, then it acts, let us say, as a PRPG. If C0, C1 equal to 0, 1, it acts as a shift register. If C0, C1 equal to 1, 0, it acts as a parallel in, parallel out. And if C0, C1 equal to 1, 1, it acts as a multiple input signature register. Okay. So we could build such a BILBO register, and that can be a good building block for BEST. Okay, so this is possible. Okay, so what we will do then is, see, suppose we have a circuit, let us say an ALU, which receives two registers and produces one output. So there are three registers, R1, R2 and R3. So what I could do is I could build these using BILBOs. So ALU is a circuit under test. Let me call it B1, B2, B3. So these are all BILBOs. So what I could do is I could configure B1 and B2 to act as PRPG. Configure B1 and B2 as PRPG. And configure B3 as MIS. And that would help me in testing the ALU. Okay, apply reset, apply test vectors. Okay, that means random test vectors by clocking the B1 and B2. So random values will be applied to the ALU, and the output of the ALU will be compressed in B3. So we can do, let us say, a certain number of vectors. See, suppose this is a 8-bit ALU. Okay. So we can do a few hundred vectors, let us say 200 vectors. And then compare the signature of the BILBO B3 with the expected signature. And if they don't match, we believe that there is some problem. Okay, there is a fault somewhere, maybe in the ALU, right? And how do you load B1 and B2 with the signature? See, suppose, I'm sorry, how do you load B1 and B2 with the seed? Usually, if it is 000 as is the seed that we have to apply. So usually seed must be placed in B1 and B2. Okay, that can be done by first configuring them in parallel. Configure B1, B2 as parallel in parallel out registers to load the seeds. Then we can configure them to work as PRPG. Then configure B3 as a MISR. Then when you are done with the testing, B3 can be configured as shift register or serial in serial out to scan out the signature that was generated. So that is the advantage of a BILBO. Okay, the BILBO allows you to sort of so there could be another test vector which is like this. I'm sorry, there could be another architecture like this. R1 and R2 are going to the ALU. And maybe there is some other circuit here which is feeding R1. Okay, so maybe it is some barrel shifter or something like that. Okay, and the same barrel shifter may also be feeding R2. There may be another register R0. So we can decide how to do, plan the test. So first maybe we want to test R1, test barrel shifter. Okay. For that we'll have to configure R0 is PRPG. Okay. R1 is MISR. Or you could configure R0 as PRPG and R2 as MISR. It may not be a bad idea to do both. Okay. Because there may be wires which are bad here, right? R1 may be great, but maybe some wires here may be bad. Okay, or these wires could be bad. So we can do both of them one by one. Plan the testing, right? And in the third step, you can make R1 as PRPG, R2 as a PRPG also, and R3 as MIS. Okay. So in general, a large SOC has a number of registers. And combinational logic, okay, like barrel shifter, ALU, they are all combinational logic. So by suitable planning, you should be able to test all the combination logic, you know, all inside the circuit. See, there is no tester now. There is no external tester. We are depending only on the internal circuitry. The PRPG is internal. I mean, they are existing. Uh, the circuit already had R1, R2, R3, etc. So we are simply reusing them in the test mode. Okay. So we are reusing registers R1, R2, etc. So that is an advantage. So the advantage of reusing is no additional circuitry. The only thing is in order to convert a register into a BILBO, you may have to add a few extra gates, right? So some extra XOR gates and some wiring may be required to or multiplexers, right? Multiplexers will be required to convert uh, an ordinary register into BILBO. Okay. So to convert a register into a BILBO, we will need some muxes and wiring. So this will be the extra area that we will end up, sort of bringing in, but otherwise it is straightforward. So I hope that helps you in understanding logic based. Okay, so I will leave it as an exercise. Design a 4-bit BILBO. In circuit bus and verify its operation. So that will be the exercise, right? So I'll give you a hint on how to do this. So first let us understand how we can convert. Let us say this is a 4-bit register and we have taken 4 flip-flops. See, if you are doing parallel in, parallel out, okay, then the D input comes from P0, P1, P2, P3. And if you are doing serial in, serial out, then this guy has to come from Q0. So we can multiplex these two guys. Okay. Similarly, we can multiplex these two guys. And we can multiplex these two guys. So these are muxes. And here also mux. The serial in will be the other input, and this is serial out. So this is a 2 to 1 mux. Okay, it has two ports. Let us say 0 and 1. So if you set the mux control to 0, then this path will be activated. So it will act as a parallel in, parallel out. It will load whatever is in P0, P1, P2, P3 into Q0, Q1, Q2, Q3. Whereas if it is if mux control is 1, then serial path will be loaded. So it acts as a serial. So with this 1-bit control, we have a PRPG. I'm sorry. We have a PPO or parallel in, parallel out, or a CISO, which is serial in, serial out. If you add more multiplexers, right, or if you add a 4 to 1 multiplexer, which has 0, 0, 0, 1, 1, 0, 1, 1, 4 ports and 2 control inputs. So in the parallel in, parallel out mode, you can connect the P0, P1, P2, P3. Okay, P0 will be connected here. Okay, 0, 1 could be serial in, serial out. Okay, in which case we are doing the way we are doing here. If it is linear feedback shift register, you have to control 1, 0, and if it is a MISR, you have to control 1, 1. So that is a hint. Okay, so use this hint to build a BILBO. You will also find papers or books also describe BILBO. Okay, for example, the book by Bushnell and Agarwal, or the book by Professor Brewer, okay, Abramovich and Brewer. Brewer and Friedman. So either of these books, they will tell you how to construct a BILBO. Okay, so you can take that as an exercise and